So now you've just seen what the three elementary operations are. Let's look at how this is going to help us. So let's start with a system. We have this 2x plus 3y equals 5 and x plus y equals 12. And what we want to do is apply the third elementary operator. So what we're going to do is we're going to multiply by -2 by the second row and then add it to the first row. So this is going to be our first row, R1, and this is going to be our second row, R2. Okay, but why are we choosing this particular number, y -2? Well, what we're doing is we're setting up for an elimination. And you all know how to eliminate variables already. That solving systems by elimination is something that is a review topic at this point, right? So if I multiply this second equation by -2 and then add it to the first row, first equation, that's going to eliminate the x variable. So in fact, that's really all we are doing here. These elementary operations are really just formalizing the process for elimination. But right now, we just have two equations and two variables. We want to sort of formalize this process so that we can deal with the same sort of idea of elimination, but with more variables and more equations. Okay, so let's introduce some notation. We have our R1, R2, as I just said. So that would be the first equation, the second equation. And we're going to multiply, excuse me, -2 times row 2 and then add it to row 1. Now you're probably not going to have to write out all the steps that I did here quite so detailed, but I wanted you to see what was happening. Okay, so -2 times row 2, let's give row 2 a color. So all the terms of row 2 are going to be in blue. So if I take -2 times the x term, and then down here, I'm going to have -2 times the y term and -2 times the 12, right? And then what I'm going to be doing to that -2 times row 2 is I'm going to be adding it to row 1, right? So I'll call that green. So this is here's my row 1 x term, here's my row 1 y term, here's my row 1 constant term, right? So let's look at what we just did here. We have -2 times row 2 plus row 1 for the x term, plus -2 times row 2 plus row 1 for the y terms, and then likewise the same thing for the constant. So as expected, the x term is eliminated. So what we get here is we get 0x plus 1y equals -19. Okay, and so now we've changed the system from these two equations to row 1 stayed the same, but now row 2 is just y equals -19. So if we look at this system with sort of fresh eyes, since I've written all over it, right, we have this system 2x plus 3y equals 5 and y equals -19. How would you solve this system? This is an easier system to solve than the original because I'm ready to just substitute y equals -19 back in. So this is going to get substituted back in for y. So I have 2x plus 3 times -19 is equal to 5. So now I solve for x. I have 2x minus 57 equals 5. And so if I add 57 to both sides of the equation, I'm just left with 2x on the left equals 62. And dividing both sides by 2, I get x equals 31. So what is the solution to this system? The solution is the ordered pair, 31, comma, y is -19, right? So this was our y value. Here's our x value. Okay, and so we've solved the system, and of course this was pretty simple, right? Once I did the first elementary row operation, I eliminated one variable, I'd solved for y, and then I just had to back substitute. Again, this should all feel like review. We've done this. Why, Dr. Hall, are you going through this? And the answer is I want us to really formalize this process so that we get to more variables and more equations. We understand what's happening. Okay, so how does this solution compare to the solution of the original system? Well, it should be exactly the same, right? These are supposed to be, if we did just elementary row operations, which we did, we should still have an equivalent system, right? So let's go back to the original system. Right, we had 2x plus 3y equals 5, and the other one was x plus y equals 12. So if we tried to solve this system by elimination, of course, we'd really just be repeating what we just did. But let's look at solving it just a different way, just to really convince ourselves that this is the same. So say, for example, I solve for y here, and I do a little substitution. So I'm going to take 12 minus x and substitute it in for y. So I have 2x plus 3 times 12 minus x equals 5. And so 2x plus, if I distribute, 36 minus 3x equals 5. Combining like terms on the left, I have negative x plus 36 equals 5. And then subtracting 36 from both sides, we see we get negative x on the left and negative 31 on the right. So we divide both sides by negative 1. And again, we get x equals 31. We still have this last step here where y is equal to 12 minus x. So we still have to substitute that x value in for x to solve for y. But certainly, we not surprisingly get y equals negative 19. So we get the exact same solution. And so again, this example illustrates why this third elementary operation works, because it's really just doing elimination, right? And so we've also introduced the notation for this sort of rows of equations, and this is going to be helpful for us when we move into more variables and more equations.